Bearers of strength. Strategic ballistic missiles, armed and ready, stand guard over our lives and liberties in a threatening world. Survival may depend upon the ability of a single warhead to reach and destroy its predetermined target. To deliver that warhead requires a vast complex called a weapon system. Part of that weapon system is the air vehicle itself, the missile with its nose cone, the airframe that contains the tons of fuel required for flight, the precise flight control and guidance packages, and the mighty rocket engines that boost this missile into the sky, sustain it in flight, and keep it on its course. Ground support equipment is part of the weapon system, too. There is the launch pad with all its service facilities for fueling, firing, maintenance. The complex and far-flung ground guidance and tracking installations. There must be facilities for missile receipt, storage, checkout, and issue, and special purpose missile transport and handling equipment to move them to the launch pad. These are just a few of the ground support elements that have to be designed, built, provisioned, installed, maintained, and manned if the warhead of this missile is to reach its target. These are direct support items. Without them, no missile can be launched. The specially trained officers and airmen who man these direct mission facilities are also a most important part of the total weapon system. They have only one goal: operational readiness. In the launch control room, when the red light flashes and the countdown stops, a missile must stand waiting for the right part in the right place at the right time. A radically new logistic system can get it there fast. A hotline from launch control room to missile squadron supply triggers the emergency action. A specially designated expediter officer takes over. He passes the word to the stock room. Here, only minutes away from the waiting missile on the launch pad, are the end products of logistic support management. Spares, provisioned and kept up to a predetermined stock level, are the key to operational readiness. Only by maintaining a predetermined stock level can each missile squadron be self-sufficient. Standard procedures speed up the supply routine at the squadron. The part so urgently needed is located by bin or shelf number. Already packaged for shipment, it can be quickly selected, checked out, and delivered to the waiting expedite vehicle kept always standing by for the short run to the launch pad. Average time from malfunction to delivery of a new part, 30 minutes. And maximum allowable time, 60 minutes. From squadron supply to any launch pad in the strategic missile squadron. More often than not, the defective component is quickly removable because of modular design. In this case, it can be immediately returned to squadron maintenance shops for inspection. An important function of squadron maintenance is to determine by inspection and bench check whether it has the capability to repair the assembly. If it is judged not squadron repairable, it is shipped immediately and directly from the squadron to a contractor or Air Force depot repair facility. A simple series of supply transactions. But without data processing, it could have taken hours or days to record and transmit, weeks or months for resupply action. Now it can be recorded in minutes, transmitted in seconds, and resupply action will be initiated immediately and automatically. Essential facts of the transactions have been penciled in on pre-printed worksheets called variable data forms. Now they have reached the skilled key punch operator. He goes first to the squadron master card file. In this deck is a card for every direct mission item which supports the weapon system. These master cards have been code punched before issue with all the fixed data available. In the key punch machine, all this fixed data is reproduced automatically on the various transaction cards. Next, the operator punches in the variable data required for each transaction card. They report on parts issued to the launch site, the resultant drop in squadron supply stock balances, inspection report on the failed part and the repair which is generated, and the fact, time, and method of its shipment from squadron direct to repair depot. These carefully registered holes represent reality, the interaction of human beings and hardware that is called logistics. To be sure that the story these punched holes will tell is accurate, they are independently verified in another machine that will reject any discrepancy. Only now can this basic input that may influence expenditure of millions of dollars or the effectiveness of our advanced weapon systems go forward from the squadron to the electronic data processing center. This input provides the basic information which is refined into logistic support management. It flows in from many sources: missile squadrons, contractors, Air Force depots. It reports in code each detail of hundreds of different types of transactions. The key punched cards are fed into a card-to-tape converter. Each tape reel stores the information contained on 2,500 cards, saving space, time, and money. The tape reels are read by the central processing unit, the nerve center of this electronic data complex. Actions taken by the computer depend upon previously prepared programmed instructions, monitored by the computer operator. To select the proper tape run, the operator need only press a button. For example, one run can sequentially check stock levels, update the master file, prepare requisitions for automatic resupply to the squadrons, schedule damaged assemblies for depot repair, and set up a suspense file for their return. All this in a matter of minutes. To do these things, the computer must have accurate data, carefully prepared. If the facts are wrong, the machine will give wrong answers, take wrong action. Cards must be correctly punched at the squadron level if logistics support is to work at the management level. To feed information to this electronic data processing center requires fast, reliable, versatile communications to each of the squadrons so that field transactions can be immediately and fully reported. Communications run to the weapon system storage site so that the Air Force stock from many commodity class depots is available at a single point. They also run to the contractor storage site at the factory so that contractor peculiar items can be resupplied to the squadrons on a source-to-user basis. Finally, they are installed at maintenance and overhaul facilities, contractor and Air Force, so that items to be repaired or modified can be quickly returned to the stockpiles. Fast, reliable, versatile communications. Transceiver to transmit the punch cards upon which all data is coded. Teletype to send supplemental verbal instructions or to clear transceiver circuits for transmission. Telephones for exceptional situations or standby emergency use. Together, these form the ComLog net linking the electronic data processing center with every element of the resupply and maintenance cycle. All this results in greater operational readiness at the launch pad, smaller stockpiles at the storage site, faster maintenance, modification, and overhaul. This applies equally to contractor or Air Force storage and maintenance sites, reduces procurement and inventory, saves money and time. Speed and accuracy in getting all the facts to the electronic data processing center, taking action, communicating that action to the right place. This is the first step in logistics support management. But now this action must be converted into hardware, and the hardware must get to where it is needed. It moves through what logisticians call pipelines. Several factors influence pipeline time. It is lengthened when transportation is slow, shortened if transportation is fast. When the pipeline is shortened, for example, by fast air transportation, smaller stockpiles are needed at the storage site. This cuts down on procurement, inventory, and obsolescence. A shorter pipeline will provide a more effective weapon system, as well as dollar savings. Keeping missiles from going out of commission for parts means greater overall operational readiness at the launch pads. Electronic data processing keeps pipelines short by automatically setting up the best routing and packaging, automatically monitoring and expediting in-transit items. Transportation scheduling is only one of the major processing runs. These runs provide constant, updated, correlated data on inventory control, all shipments and receipts, adjusted stock levels, items due in, on order, in repair, or in transit, technical data, current and precise item descriptions, configuration, the exact items which make up each individual weapon system, failure analysis, frequency and causes of failures by item, usage and attrition rates by item, cataloging, the weapon system stock list, dollar reporting, the current financial status, and requirements computations, including procurement and provisioning status. A single complete set of logistic books using a common coded language correlates every logistic support function through electronic data processing. But it does not eliminate the need for human judgment, human decision, human responsibility. This is the job of the logistic support manager. To carry out his mission of timely support and effective management of an advanced weapon system, he integrates on his staff each of the key logistic functions previously under separate organizations. Documentation of logistic support management is also integrated. Weapon managers, contractors, and squadrons, separate responsibilities and procedures are set forth in individual manuals. Staff officers provide policy input on budget, procurement, transportation, maintenance, supply, and liaison with using commands. These are combined under one logistic support manager to provide the fully integrated logistic program that today's and tomorrow's advanced weapon systems must have if they are to get and stay operationally ready. Electronic data processing takes care of all routine transactions in each of these functional areas. But the machine also recognizes problems it cannot solve, the exceptional situations. It calls attention to these problems by making a printout on the high-speed printer that is part of the data processing system. Printouts like these go directly to the manager who can make the decision, take the action needed. This is a printout on a supply problem. It goes at once to the item manager, a member of the supply staff. Decoded, it tells him of the slower consumption rate of an item that had been planned for in initial provisioning. Other information to aid him in making his decision is also printed out as needed by the Electronic Data Processing Center. Quantities on order, in transit, or being repaired. This is management by exception. Making decisions based upon electronically processed data, but requiring managerial judgment. These decisions save money by preventing overstocks, or ensure operational readiness by maintaining an adequate supply of spares. Management by exception conserves executive talent by bringing to the manager only those problems the machine has not been programmed to solve automatically. A different example of management by exception also begins at the Electronic Data Processing Center. This time, a run reveals a failure rate for a given part much higher than the programmed tolerance. This is printed out by the machine, together with a tabulation of the causes of the failure. The data sheet is delivered to the maintenance manager, another member of the logistics support manager's staff. Starting with this information, he moves to confirm and amplify it by test and analysis, the kind of expert and specialized knowledge that must come from men, not machines. To the missile assembly site come the maintenance people from the missile squadron, the contractor's technical representative, the AMC maintenance specialists. They analyze the fault that is causing failure and determine it to be a design deficiency. Findings result in further studies by research and development people and by the engineering group on the staff of the Logistic Support Manager. Their joint recommendation results in an engineering change proposal to correct the design deficiency. This is monitored by the Chief of Weapons Engineering, another staff officer of the Logistic Support Manager. This modification, resulting from early computer detection, will reduce the chance of missiles out of commission for parts. Remedial action began at the Electronic Data Processing Center with a printout, but it required human technical skills, human judgments, human decisions to solve this special and complex problem. This is management by exception. The Electronic Data Processing Center has stored on its reels millions of facts constantly updated about thousands of direct mission items in an advanced weapon system. How these items got there is a story in itself. The story of provisioning, the determination of required spare parts and ground support equipment to make a weapon system operational. Logistic support management of advanced weapon systems incorporates new techniques made possible by centralized management control and electronic data processing. These are designed to obtain the greatest dollar mileage for the taxpayer and the most effective support for operational units. To explain them to the contractor, the Logistic Support Manager schedules a provisioning guidance conference. His staff covers such specialized concepts as periodic ordering. This breaks down estimated yearly requirements into quarters or even months, permitting constant reevaluations on the basis of actual consumption. Production responsiveness. This calls for the contractor to maintain many items as unassembled parts. These can be rapidly assembled for replacements or used in production if no replacement requirement develops. This is only the beginning of the long, complex, and continuing provisioning process. Through provisioning action, the Logistic Support Manager of an advanced weapon system is given a timely, well-documented, flexible stock of direct mission items and spare parts. He manages these through an integrated staff representing each of the logistic functions. Supply in weapon system storage sites, contractor storage sites, and squadron supply areas. Maintenance and tech order modifications performed at contractor or Air Force maintenance sites, or in the field by squadron maintenance or mobile maintenance teams. Funding and accounting operations, specially geared to the needs of a single logistic support manager and the contractors. Procurement, whether for end items, ground support equipment, or spare parts, is also responsive to the logistic support manager's deadlines. Transportation, including specialized packaging and record keeping, will ensure safe arrival within the fixed time set by the logistic support manager. All of these logistic functions are tied together by shorter pipelines. This means smaller inventories, less dollars tied up in spares. Electronic data processing. This means assured and timely support for the missile site. ComLogNet communications. This means rapid and versatile data flow from squadrons and storage sites to the Electronic Data Processing Center. Here the actions are taken that support the missile on the launch pad. A tower of strength, an advanced weapon system in all its complexity. The ballistic missile, the ground support, the spare parts, the trained men. It must be ready. Logistic support management makes and keeps it that way.